This week for Calc 2, we're going to be talking about the line of intersection of planes. In order to find the line of intersection, we're going to have to take a cross product. So let's look at what that is first, graphically. If this is your vector A, and this is your vector B, the cross product of A and B is going to be upwards right here. So if we have our two planes, we want to find the cross product of the normal vectors when we find the line of intersection. So the first normal vector is going to come out of the page this direction, and this is n1 for my first plane. And then your next one is going to come out of the page this direction, and this is n2 for your second plane. So then their cross product is going to be just like on here, it's going to go upwards this direction. And we see that that is the line of intersection of the two planes. So let's get started on finding that line of intersection. So first we need to find a point of intersection. So in this case, to make our numbers easy, we're going to use x equals 0. So if x equals 0 in these two equations, we end up with negative 5y plus 3z is equal to 12, and positive 4y minus 3z is equal to 6. So then we're solving for one of the variables. So if we add these together, we get negative y is equal to 18. Which means y is equal to negative 18. Next, we plug this in to find z. So we have negative 5 times negative 18 plus 3z is equal to 12. So if we solve this, we're going to keep going and we get 90 plus 3z is equal to 12. So negative 3z is equal to 78. And so z is going to be equal to negative 26. So now, putting all those three together, we end up with our point that we know both of the planes are on. And we have x is 0, y is negative 18, and z is negative 26. So next we need to find our normal vectors. In order to do that, we're going to need to take a cross product. And we're going to need the normal vectors of the equations to take that cross product. So the normal vectors are just going to be the coefficients of your equations. So we're going to get, for this one, 2, negative 5, 3. And for this one, 3, 4, negative 3. The cross product of these two vectors is going to be your direction vector for the line of intersection. So let's do the cross product. We have I hat, j hat, k hat. 2, negative 5, 3 is our first vector. 3, 4, negative 3 is our second vector. If we cross these, we get I hat times the matrix negative 5, 3, 4, negative 3 minus j hat 2, 3, 3, negative 3 plus k hat times 2, negative 5, 3, 4. And if we do all those determinants, we're going to get this vector 3, 15, 23. So this right here is the direction vector for our plane. So all we have to do now is combine them to get our final answer. So we're going to get r, because we want a vector, is equal to our direction vector we just found, 3, 15, 23, times t, plus that point we found, which was 0, negative 18, negative 26. And that's our final answer. You can multiply it out for a value of t, so say t equals 1, and then you can plug it back into these equations to check if your work is correct.